Hello everyone, my name is Jim Beretta and welcome to another CFIN virtual experience. Today's presentation is called Robotics in Action, Seeing is Believing. Before we start, we'd like to give a big thanks to our sponsor, FCC, who lends money and provides knowledge and insights to support the food industry, including small business owners looking for $10,000 or a publicly traded company needing $150 million. FCC has a Canada-wide network of financing and industry experts with the experience and knowledge required to help you grow your business, take advantage of new market opportunities, and innovate to become more efficient and sustainable. I'm very honored to be here today as your host. Aside from being a close friend and colleague to CFIN, I'm also the president of Customer Attraction. We're a marketing consultancy focusing on robotics and the automation industry, and I spend a lot of my time talking about robotics, automation, and applications. Today I'm excited to show you how technologies like machine vision, data, robotics, and automation will transform all aspects of the food industry. We'll showcase the Canadian disruptors who are paving the way forward and talk about the big challenges ahead for the next decade in the food industry in Canada. If you're like most people, the word robot conjures up an image that they've seen in movies or in TV shows. The bulky Rosie on the Jetsons, a lumbering heap of metal from the 50s B-movies, or a futuristic humanoid like the Cylons in Battlestar Galactica. In reality, robots being used in food processing and restaurants are nothing like any of these. Robots today are becoming more streamlined and more practical, designed to do the jobs alongside humans, the tasks that are too dirty, repetitive, that cause injuries, or are dangerous to people. As some background, let's talk about why robotics has become so popular in the industrial sectors. Robots are a great value for manufacturers as they can last 10 to 20 years. And over the past 10 to 15 years, their costs have been falling while performance has been rising. So let's add in another few benefits of automation, and the case for robotics and automation becomes even more compelling. Robots provide consistency and quality, a very important factor in all industries, but especially in food. The scarcity in labor has created a demand for robots and for all automation. Robots can address repetitive tasks and say fill in on things like pick and place, allowing people to be deployed in areas where they add much more value. Supply chain has become extremely disruptive and fragile due to the global pandemic. Optimizing scarce resources, reducing food waste, reducing power consumption, and improving profitability are all achievable using automation. And let me show you something that I found pretty interesting. That's a lot of fun and it's pretty cool. What you're looking at is some footage from the DARPA Robotics Challenge that was run from 2012 to 2015. DARPA is an acronym for the U.S. Department of Defense Advanced Research Projects Agency, or DARPA for short. They developed this exercise to get robots to complete complex tasks in dangerous, degraded, human-engineered environments. 16 teams competed in the challenge for over $3 million in prizes. The robots had to drive a car, they had to walk upstairs, close a valve, open doors, things that you would want a robot to do in a dangerous situation. Competing students, professors, and roboticists cringed as their $1 million robots fell down, and they fell down a lot. Fast forward to 2022, just a mere 7 years later, and we see that robots have nailed down dancing. Spot Mini is the canine-looking robot. Okay, let's call it a robot dog. Atlas is the large white robot, and Wheels is a material handling robot. So how does this fit into the food industry? Compared to other industries, the food industry has been slower to adopt and invest in automation for a few reasons. Aside from expense, early robots were often slow, complex to integrate, and often not dependable. Despite the fact that using robots improves food safety, manufacturers were comfortable with human labor, and if they needed to ramp up, they just hired more. However, now, with the shortage of labor in North America, companies have had to look at other ways to maintain productivity and delivery while reducing costs and keeping quality high. In today's program, I'm excited to tell you that we have lots of smart people to talk about the ways that they're seeing automation change the way they operate and do business. First up, we're going to take you to Western University, where to increase convenience, reduce costs, provide food service for students and staff during off hours, automation is changing the game. Let's take a look.
Brady, thanks for joining us for this conversation.
Thanks for having me.
Brady, how did Western get started with automated food kiosks?
Really, we're just looking for an opportunity to provide food services for our students outside of the regular operational hours of our current operations that we have here at the UCC. We originally started with just the Theos coffee, and then we went to the salad machine, which came in about a year ago, and then we introduced the pizza machine just in January.
Brady, can you give us a demo of what we're going to see here?
Absolutely. So when the students walk up, they would simply just touch here to start. They get their choices of 7 different pizzas. I'm going to, for sake of just choosing one, I'm going to choose a regular pepperoni today. You get your choice of either cold pizza to take home and cook on your own, or you can choose a hot pizza. Right now, actually, we're providing a 50% discount, so it is half off the regular price. And then the student would just hit this to add that to their order, confirm that this is what they would like to order, and then simply provide your form of payment. Today I'm going to be using a coupon code, so I'm going to hit coupon, and the order has been confirmed, your pizza's on its way, and then you can get the receipt emailed to you, or it'll actually spit out of this area right here. So I'm going to hit yes, and now we wait.
Nice. And so how long does this take?
So each pizza takes approximately about 3 minutes, and then you can actually watch the pizza being cooked around the corner on the front of the machine as well.
What are some of the challenges that you found with automated food dispensing?
Some challenges could be, spur of the moment problems the machine might have. Payment processing, which really hasn't been that much of a challenge besides just the integration with our meal plan on campus.
How is the engagement going with students?
It's good. We're doing a full rollout of the program with proper engagement and promotions in September of next year, because we've still been kind of launching it softly over the course of the past, 5 to 6 months. But the engagement has been really positive, and the students are accepting it, and they're curious.
Well, that's great.
Yeah.
It sounds very exciting. It's very interesting, and thank you very much for joining me.
Thank you.
You can imagine that these automated food kiosks will grow more and more popular in campuses, in malls, and other public spaces in the near future. But let's now talk about how robotics are changing the way that we grow and harvest food. Anyone who gardens knows that nature seldom creates perfect replicas of fruit and vegetables. But consistency is essential for autonomous kitchen kiosks like we just saw at Western to function properly. So we went to Mycionics to meet the innovators who are using technology to ensure that mushrooms sent to these new food service concepts are as standardized as possible. Here we are at Mycionics in Putnam, Ontario, where we're going to be talking to some of the people who are revolutionizing mushroom picking using robots and automation. Michael, thank you for letting us come to your facility for a tour and a chat.
Thanks for coming, Jim.
Tell me what Mycionics means.
Mycionics is a blend of mycelium and bionics. So mycelium is the mushroom body, basically. Mushrooms are the fruit, and mycelium is the body, which is running underneath the ground throughout the world. It's the largest organism in the world. And then bionics leads to robotics.
So why automation, and what are some of the motivators for you getting involved with the Mycionics?
This company was founded by Murray Good, who's a mushroom farmer himself, and this is his farm, which recently just doubled in size because of the growing demand for mushrooms. But labor's been a massive problem in the industry, and it's only getting scarcer and more expensive. In Canada, there's about a 20% labor gap where they cannot get enough people to pick the mushrooms. There's about a 40% labor turnover, so switching out people year on year, and it takes 4 to 6 months to train someone to proficiently pick mushrooms. The mushrooms are very delicate. You can't touch the tops of them when you're harvesting them. So that's really the reason that Murray partnered with the University of Western and started to develop robotics to actually pick the mushrooms. It's back-breaking, repetitive work in high humidity rooms, and people not like doing the work. So by picking them robotically, our system is able to graze harvest, basically, only picking the ones that are at the right size and waiting for the others to grow up to that exact size that the retailers are looking for.
So Stefan, you've got a really exciting job, right? You get to invent new products. Let's talk a little bit about kind of the products that you've created.
Yeah, I am very blessed to be in this opportunity to take a project from the academic stage all the way to the industrialization stage and solve a problem that the industry is desperate for. And in essence, we didn't have a lot of inspiration to look up to in the field other than other common smaller subsystems of our system. So we had to basically do a lot of things ourselves. We developed our own 3D scanner, our own harvester, our own gripper that picks the mushrooms, our own finger designs, and then that also led into the lifting mechanism that lifts the harvester from different levels of the bed, and then finally our packer that receives the mushroom, cuts the stem off, and packs it into a box. The majority of which we developed ourselves using common electromechanical and processing systems available on the market, but we put that together in a package using a team of mechanical, electrical, software, firmware, and artificial intelligence engineers back at our headquarters.
Can you tell us a little bit about the actual vision processing? So do you actually create a point cloud with the vision system?
That's right. So we developed a custom 3D scanner that we attached to our harvester. We were not able to find anything off the market that would suit the requirements. And mostly the reason why is because of these beds. There's a very little amount of space between each bed, and the mushrooms are very close to the cameras, yet we have such a wide field to scan. So we developed a system to laser 3D scan the mushrooms very rapidly and precisely required for industrial requirements, and that's mostly based on the generation of 3D point clouds.
So then what's the process? The scanner comes on and does what?
The scanner comes on and our harvester moves forward, and the red laser line everywhere where it's seen by the cameras, that gets converted to a 3D point. Once we have a section of the bed worth of potentially up to 300 mushrooms or so, we run that through a series of algorithms and artificial intelligence that determines each individual mushroom, its size, position, orientation, its space, and essentially its desirability in terms of picking. And finally, the strategies for our harvester to actually use and harvest the mushrooms without damaging it or anything around it.
So it's got the map, it's got the plan, it executes the plan, then you have a cutting system.
That's right. So our harvester takes care of the scanning, detection, and the picking side of things. But once it has the mushroom in its hand, it has to pass it off to our packer, which rides along the side of the bed rather than inside of the bed. And our packer receives that mushroom, cuts off its stem, and then places that mushroom precisely in a box so that its cap is facing upwards, and that's where the box gets weighed and the individual mushroom size itself gets weighed. Once the box is full, that box automatically gets replaced with an empty box, and the process continues for up to 24 hours a day.
So what's been the biggest challenge? Has it been like just everything, or has it been actually building the robot itself because it's got a humid environment?
The biggest challenge I would say for the very beginning of the project is developing a robotic system that would fit in this space. We're very tightly constrained by space in general, and we had to fit a very complicated system within that space, as well as a vision system in that space. So putting that into a package that actually works in this environment, it's a very high humidity environment. It's not the most ideal for robots in general, but once you had a system that can actually survive in this environment, then the next problem was actually determining where the mushroom is precisely, how big it is, how it's oriented, and how to pick it as well. We actually discovered a lot of problems along the way, problems that require a lot of engineering and trial and error, and hence why this system like this has never been successfully commercialized before. But we are there, we made it, and now our biggest problem is how to scale up, how to grow, and not actually how to provide the solution to the global market.
No, it's a very exciting opportunity, and I think of all the farming people in the farming industry, young roboticists, people looking in going, wow, this is really possible even today when you think everything's been invented, but it really hasn't. Mm-hmm. So what's on your next long-term radar or short-term radar? We talked earlier about artificial intelligence and about data mapping.
Our next big interest is how to actually optimize the process so that we can improve the yield and the quality of the mushrooms in general, and also help the farmers grow better mushrooms. And we can do this through the fact that we collect an enormous amount of data in order to simply operate. We have to know where the mushrooms are, we have to know their size, we know the climate that they're in. These rooms are heavily climatized in general, and the process of growing mushrooms is very dependent on the climate that they're in. So we believe that with the use of data analytics and artificial intelligence, we can optimize the growth of mushrooms and the quality of mushrooms being produced today at the market, and hopefully stimulate the industry even further.
Stefan, thank you so much for taking some time and explaining the
Jeff.
technologies. Next up in our program, we have a revolutionary standalone robotic food service system that can prepare perfectly cooked and portioned wok-inspired meals with no human employees at all. Let's take a look at the new Rowbot system.
Hi everyone, I'm Nipun Sharma. I'm the co-founder and CEO of SJW Robotics. We have developed the first QSR restaurant with 0 on-site employees. Our system of cooking employs the structure of a wok. This is a robotic wok called Rowbot, and I'll quickly explain to you how the food cooking cycle works in our machine. This side of our machine is a refrigerated component. This is where we store our raw materials, our vegetables, our proteins, our sauces. The moment someone places an order in Rowbot, they dispatch the required quantity of the food, and that food goes into a gantry system and moves to the next level. On the next level, we have our noodle gantry, which is where the required amount of noodle volume is dropped into the cooking basket. And the third component after that is a steam tunnel. The steam tunnel allows us to warm up the food before it hits an actual wok. So the last interesting part of our cooking cycle ends with our automated wok system, the Rowbot system, where the food is prepared pretty much with the same sensibilities as a regular wok, where food is tossed, rotated, and turned. It gets caramelized by a wok that's heated at 400 and 500 degrees Celsius temperature. And when the cooking cycle is complete, which takes about 60 to 80 seconds, it gets dropped into a bowl, and from the bowl, it gets delivered to the side windows. You tap your phone, you pick up your meal, you're on your way. We have created the first fully autonomous robotic restaurant that cooks made-to-order meals from scratch.
Hello, my name is Brian Walker, CTO of SJW Robotics. Rowbot is revolutionary because it's truly using advanced cloud-based analytics to truly monitor all operations within the machine. Because we do this remotely, we can manage this machine off-site, looking at predictive analytics, also adjusting to changing consumer needs with regard to food, recipes, or the like. And we've truly taken advanced manufacturing techniques from the automotive industry and transformed them into what you see today as Rowbot. So welcome to the future. With Rowbot, we are merging the art of cooking with the science of automation.
My name is Pierre Jutras. I am the co-founder of Rowbot. As a restaurant owner and operator, I know firsthand about the challenges that are hitting our industry, specifically with regards to labor.
As an investor in Rowbot, I'm super excited. I think we could see these machines replace QSR locations all over the world. We could see them, they give you versatility, they allow you to operate without employees and make food accessible at a cheaper price point. It's a win-win-win. Actually really impressed with the food. It was freshly made, warm, good tasting, better than the Thai restaurant down the street back home.
Well, the investor in me is super impressed because I just had one of the best pad thais in my life. And believe me, I've had a lot of pad thais in my life. And the fact that it was all made fresh, automated, by a beautiful machine, like I feel like we're living in the future.
Our goal is to serve you the best food you've ever had in a sustainable and carbon positive environment.
Nipun, welcome to the presentation today. We're keen to learn a little bit more about how automation and robotics has worked into your solutions.
Well, thank you for having me. I'm excited to be a part of this.
So I'd like to first ask, how did you first think about this as a solution?
To be honest, we had no intention of starting a robotic startup. It's not my wheelhouse. I'm from the restaurant industry. I've been doing restaurants for 17 years. Everything you can think of, from steakhouses to vegan and everything in the middle. My new project was with Loblaws to create a restaurant inside a grocery store, a grocerant. It's called Global, bowls from across the globe. And the idea was to create this new experience for Loblaws customers. And that opened last year at Loblaws Maple Leaf Gardens. Having somebody like Loblaws as part of our ecosystem, that means we could scale up super fast because the real estate is already captive. So our new problem was, how do we find labor? How do we find employees? We had situations where people didn't even apply for the jobs that we had put out, and we knew scaling up with the labor shortage is going to be a bit of a challenge. So I went on a quest to find robotic companies that could service my needs. I contacted every company in the world. Can you build me something that I can use at my restaurants? I didn't find anything that was fantastic for my personal needs. So we went on a quest to start our own company. What does it take for us to create a holistic solution that addresses all the shortcomings of a traditional restaurant? How do we make something scalable? How do we make something at high speed and high volume? And we put our heads together, and 2 years later, we created what you just saw.
And what was one of the greater technical challenges that you've had with
If you ask my engineers, the word broccoli will bring out a lot of tears. It took us 2 months to find out how to properly dispense broccoli because of the texture and the shape. We had to invent a new way of dispensing it accurately. So that was probably the biggest challenge for my engineers.
Nice, that's good to know. So how much room do I need to put in one of your units?
That's the good news. This is kind of realistic agnostic. We took food trucks as an inspiration. The entire machine that you just saw is about 13 feet wide, 7 feet tall, 4 feet deep. Think of this as 3-4 Coke vending machines strapped together. It requires just an electrical and a plumbing outlet, and you're good to go.
And how many meals per day or per hour can you serve?
So the capacity of the machine in total is about 350 meals. This makes about 60 meals an hour. So in a busy location like an airport, it might need to be refilled a couple of times a day. The shelf life is typically about 3 days. So in a remote location, 2 or 3 times a week.
And what's the most common question that you get? Because you must get a lot of questions.
The most interesting question I get is, are you taking away jobs from the restaurant industry? And my response is always, we have a hard time filling these jobs. Nobody's applying for it. Nobody's showing up to work. I think a generation ago, people didn't have too many choices. Young kids, this was their first job. Other people, if you don't have anything else, you can work in a fast food restaurant. I think everybody has better choices now. Kids are starting Facebook instead. I could be driving an Uber car, working at Amazon. There's more choices. It's a job that's lived its high point. And I think like other jobs in our history as human beings, encyclopedia salesmen, water carriers, I think this is the kind of thing that needs to be automated so we improve the human condition.
And it might be a net-net, right? Because in creating these kiosks, you're actually creating work too.
Oh, absolutely. I think the dimension of the requirements of a chef change. No chef that's talented wants to make the same sauce every day. Yeah. We're 8 billion people in the world today, and even micro niches have become tens of millions strong. So people have allergens, people want creativity in food. I think that's where the talent in cooking and chef needs to go. And machines need to follow through and do the repetitive tasks, the tasks that nobody wants to do.
So what's in the future for Rowbot?
The future for Rowbot is really to meet an important segment of the food market. In my opinion, I think the food industry is going to be in 3 different segments. There's going to be food as art. That's your Chef Grant at Linea. That's your Michelin-star rated restaurants. You go there for this fantastic museum experience of seeing the future of food and molecular gastronomy, all that good stuff. And that's really expanding and it's becoming more accessible. And that's going to be fantastic to experience. I think the second category is restaurants, full service restaurants, where you go for the experience. We go for families and celebration. You go with your colleagues, you go with your family. You go there for the experience as much as you go there for the food. And I think the third segment, which is more than 50%, is your functional food segment. The food that you eat in your car, the food that you eat while watching Netflix, the food that you eat while working on your desk. And what do you need for that? You need it to be fast, you need it to be great tasting and maybe healthy. But convenience matters. And what matters also is value. If you think about an average restaurant, food is only about 30% of your costs. Right. 50% is labor and occupancy. So if we can take away that inefficiency in the model, give you the same great quality food at a significantly lower price, we deliver value. So I think that's where we fit in. I think that's the future of food.
And thank you for that. It was really, really fascinating. When you think of your bullseye customers, who are they?
Our customers are people that order from ghost kitchens, people that like delivery, people that like convenience, people that want food fast. So oddly enough, everybody.
That's great. Well, thank you very much for joining us today. I know we learned a lot, and I appreciate you sharing your invention with all of us.
A pleasure to be here.
Our next guest joins us in studio. Tharwat, thank you for coming and joining us.
Thank you for having me.
You're president of Anubis 3D. So can you tell me a little bit about what you do at Anubis?
So in Anubis, we are a 3D printing service provider and producer of end-of-arm tooling, robotic end-of-arm tooling.
So just for our audience, what is an end-of-arm tool?
Well, an end-of-arm tool is actually the hand of the tool. So the robot comes in as an arm and it just doesn't have any hands. So the end-of-arm tooling is the tool that attaches to the flange of the robot to perform the task picking or dropping or performing any tasks.
And in an industry which is hardened steel and aluminum, and people are very used to traditional end-of-arm tools, do they kind of look at you sideways when you talk about 3D printing your end-of-arm tool?
At the beginning, for sure. I mean, the first round of trying to get to meet people was very, very hard. We were immediately dismissed not to even want to have meetings with us. 3D printing, we don't want it. And as soon as we get into the room for 5 minutes talking about what the process and what it does, show them some tools, this is where 5 minutes later the room is full of engineers very excited, interested to listen and learn about it. It's all about how we build it, and this is what makes a difference here.
And what are some of the advantages to a 3D printed end-of-arm tool versus a traditional subtractive method of building a tool?
Well, with 3D printing, you have several advantages. First one is the lightweight, and you can achieve that by using plastic instead of aluminum, most of the cases, or stainless steel. And you can also do that by reducing the mass of material. So you can design very intricate structures that can reduce the material to the minimum material required to carry the load. So the tool becomes very, very light.
And what about some of the new flexible materials that you're dealing with? Can you tell our audience a little bit about that?
We primarily use 3 or 4 different types of material. 9-on-12 is the most commonly used. We use glass-filled aluminide, and those are the kind of materials we use all the time in tooling. Because of 3D printing, you can do what we call topography optimization or generative design, which are basically a program that goes in and puts material only when you need it and then moves it anywhere else, making the structure look very organic, but also strong only when you need it and much lighter than traditional. So this is something you cannot do with subtractive technology because physically you cannot machine parts of that nature. So we have bottle grippers, for example. It wouldn't be possible to have that concept unless we had a 3D printing capability. As the design gets more complicated, you need people to spend the time to design.
Right.
And that is it becomes more expensive than the traditional. Once you finish a design, the manufacturing becomes a lot cheaper and a lot more economical.
So best practice, from your perspective, is to have your customer approach you a little bit early in the process.
We usually often get involved when our customers are still building their quotations or building the conceptual design. They bring us in early, and that gives us an opportunity to take advantages of all the 3D printing capabilities.
Darwin, thank you very much for coming in today. We've learned a lot, and this is a very exciting part of meshing kind of traditional automation with kind of new technologies.
Thank you very much for organizing that event. It was very helpful, and we're very happy to be here. Thank you very much.
Next up, we have Christian Tezbazian from Gastronomus joining us in studio today to talk more about AI chefs or robot cooks, whatever you call them. He's the one that can give us more insight into what is happening now and what we can expect in the future. Christian, welcome to our show.
Thank you very much, Jim. Happy to be here.
You're COO and co-founder of Gastronomus.
Yes, sir. Very proud to be.
And you brought some video today.
Yes, why don't we take a look at it, Jim? So what you see here is the first thing that Team Gastronomus put together. We got to put together something. In 1 month, we had no real engineers. We had no really big resources. At that time, I was still a student, computer science student at the University of Waterloo. So we said, okay, we got to put together something by the end of this summer which demonstrates, number one, our capabilities. I mean, the technology that went into that is not an easy task. You got fully automated dispensers, washing machines. You got robots working together in a shared kitchen environment. So that was one aspect, to demonstrate what we as a team are capable of. But second and most importantly, it was to begin initiating discussions. Far too many times startups, not only in this space, but in any space, make the mistake of spending years building the first thing without getting any sort of feedback. Mm-hmm. We could not have that. So we said, we got to put together something quickly to be able to bring in customers, bring in suppliers, and Jim, we must have run 500-600 shows. I mean, I ate so much pasta, it was out of this world. So yeah, it was a great piece of technology to begin initiating discussions and really learning about the market. A lot of people ask, can I have that in my kitchen? Look, it is definitely something we could do, but there are much more pressing needs right now for our customers and for this market in general. That's the end goal, but there's many more steps in between to get there.
So, Christian, what's the market for automated robot chefs?
What isn't the market for automated robot chefs? I mean, food. Food is the oldest thing. I mean, since there was the first human, there was food. We have to have food, 3 meals a day. It is the last, Jim, great frontier of automation. We look at any industry today, and that industry has undergone significant technological transformation, significant innovation over the past 20 or 30 years. But food, the way that, and I'll clarify one thing. Commercial, I'm talking about kind of fast food brands, QSR brands, commissaries, not fine dining. Those chefs, the people in those kitchens are artisans. You cannot take that away from them. But the way that fast food, QSR food is prepared, it is much like a mini factory. You got to do the same steps in the most timely, efficient, and reliable manner as possible. But so many things have changed. The market has changed, their inputs have changed, everything has changed, but the equipment that they're using, the way that they're cooking the food hasn't. Back of house, front of house, commissaries, high throughput, low throughput. It is all applicable for robotics and automation.
And can you tell us who your bullseye, who those perfect customers are for you?
Our bullseye customers are customers who want to innovate and be at the forefront of a new market. Our customers are the ones who say, we are not happy right now with how things are. We are not happy with the solutions available on the market. We want to be the ones to lead this great frontier of automation and smart technology.
So, and you're taking a very innovative approach to creating modular automation. Can you tell me a little bit about what that is?
Rome was not built in a day, and fully automated kitchens are not going to appear in a day either. You cannot go to these huge clients or any client at all and say, look, I need you to now build a brand new restaurant built around technology which is brand new into the market. It won't work. You got to go step by step. So we are pursuing a modular approach. So we're releasing and we'll be releasing very soon to the market products which focus on a very specific task in the restaurant, can very easily be implemented into existing restaurants. Very easy to clean, maintain, use, and from there, restaurants and customers can gain confidence in this sort of new technology, as well consumers can gain confidence in this sort of new technology. They can pilot that, begin rolling it out, and then put in the second machine, the third machine, the fourth machine, so on. And on the back end of things, these are all going to connect together.
And you've had a lot of interest from around the world, and what gets you most excited about the technology?
Working with a great team and working with great customers to develop technology which is really going to lead this world by storm, and Canadian technology. We're very, very proud of that.
I'm very excited for you. I think it's a great product.
Thank you.
And cannot wait to finally order something from a robot chef.
Thank you, Jim. Yeah, we cannot wait to serve something from a robot chef.
Thank you, Christian, for sharing your expertise today.
Thanks very much for having me, Jim, and thank you, CFIN, very much for putting all of this together.
And now a short interview with Applications Team Leader at JMP Solutions, Tom Kurowski. Check this out. Tom, welcome to the presentation.
Thank you for having me.
Tom, you're a team lead at JMP Systems, and can you tell the audience a little bit about what JMP does, especially in regards to food?
Yeah, for sure. So JMP, the Automation Robotics division, is obviously for the most part a robotics integrator. We focus on the flexibility that robotics can offer in many applications. So historically, we've been in a lot of different markets, material handling, oil and gas, consumer packaged goods. And for over a decade now, we've been in the food space. So we've got a lot of industry-leading expertise in food safety and sanitary design. Our products and our processes that we deal with are very ambiguous. They vary a lot. So we get into some really unique challenges with the applications that we take on. Outside the technical, we're involved with a lot of plants that are new to robotics. So we deal a lot with the human element of our solutions as well. So coaching and guiding our customers, setting expectations around automation, stuff like that.
It's an important part, certainly, of the automation puzzle. And what types of automation are you building? What types of food are you building automation for?
It's a good question. So the biggest need that we see is in protein. So poultry, beef, pork, and directly handling the product. The other thing that we see a lot of is what's called RTE, which is ready to eat. So in those applications, we are touching the final product and putting it into a package. So it's similar to the protein space in the sanitary design, but the difference with RTE is that the sanitary requirements are actually more stringent. Because if you think about it, when you buy drumsticks at the store, you're going to cook them, and you're going to cook them thoroughly. But if you buy a taquito or a burrito, you might just put them in the microwave and heat them up. We're also seeing a larger variety of robots that can be used in the food space, targeted for sanitary compliance. We see a lot of computer vision really develop. That's when you'll start hearing things like AI or deep learning.
And you brought a video to show us, so let's roll that video. And maybe you could talk a little bit of what's going on.
Yeah, absolutely. So this is the high-speed sandwich line. We are assembling sandwiches. We take bread, we take the buns tops off of the bread, we add protein of different varieties, and we add some toppings, and we put the bun tops back on. That high-speed sandwich, it's a really good example of things looking easy because we've designed the process surrounding the robots to work really well. So one of the biggest challenges is to ensure that, for example, every single cleat is full with a bun on that conveyor. Because each sandwich goes to an overwrapping machine where they get individually overwrapped. So if you have an empty cleat, it means that you produce waste if there's nothing there. And if there's an empty cleat, then you're also overall going slower.
What about Industry 4.0? Is that something that's becoming more important to your food customers?
Yeah, so Industry 4.0, I mean, it's a big topic. It covers a lot. So for JMP, I think it's really giving us the ability to monitor our equipment, gather data and correlate it to trends that can help identify things like preventative maintenance, detect if there's non-optimal run settings, or prevent situations that could, maybe lead to decreased throughput, stuff like that.
Tom, thanks so much for spending some time with us today. And we wish you good luck. And I know things are very busy for you right now. So thanks again for joining us.
Great. Well, thank you very much for having me.
I don't know about you, but this is pretty fascinating stuff. So let's keep things moving, and another disruptor making waves by adding so much efficiency to their clients' operations. We had a chance to visit an automation systems integrator, Armo, not too long ago. Armo is a leading builder of special machines and automated solutions in southwestern Ontario, where food, beverage, and cannabis industries are being introduced to robots, conveyors, and custom solutions. So let's make our way to another Canadian company who is literally changing the game. We're here in London, Ontario at Armo, and I'm talking to Ben Whitney. Ben, thank you very much for allowing us to come in and chat with you today.
Thanks, Jim. My pleasure.
You're a vertically integrated automation house. What does that mean?
So what that means is a lot of the subcomponents that go into the work that we do, we build those in-house. And that's a real advantage, particularly during today's supply chain disruptions, so that we can control the delivery and the quality of the subcomponents that go into the automated solutions that we design and build. With a modern robotic solution, some of the flexibility that used to be challenging, where a box size is changing or a product size is changing or a product is organic in nature and a little bit varying in its size, those problems can be overcome now that used to be quite difficult.
And you're seeing from your food and beverage customers, you're seeing that, right? You're seeing the Costco's or the some of the big food producers that are demanding these different box sizes and such.
Yeah, different pack sizes, and sometimes the box that we would have thought of as a backroom box that gets torn apart for the boxes that go on the shelf, sometimes that box is now the box that the customer is seeing and purchasing.
How important is the automation being easy for food and bev industry?
Yeah, it is super important. One, they don't necessarily have like a very high controls team that can support like all of this programming and so on. And at the same time, the end user, there's unfortunately such a big turnaround on stuff that you need something that it's like plug and play, sort of like your phone kind of mentality, just go and use it.
And collaborative robots mean that you can work comfortably beside automation, is that correct?
That's right. A collaborative robot doesn't require guarding in between it and a human, so you can work in much closer proximity, which often works well in food and beverage plants where the floor plan is quite tight. And it's also a great way to get your operators comfortable with robots, that they're safe and they can work close to them. And so the machine that's behind us, it fits into an existing assembly line where a skid of boxes comes, and then right now humans are preparing those boxes to go into an existing machine that's packing those boxes. So this machine takes out that very boring job. It runs, 24/7 if it needs to, at a relatively slow speed, but fast enough to serve the machine that's behind it.
Tell us a little bit about the collaborative robot and the controls. This is something that you've had experience with now?
No, so this is one of my first projects, which makes collaborative really the way to go with the robot integration. It's super easy to integrate with the robot. The whole flow control programming makes everything really seamless for something with someone not a lot of experience. That's kind of where new industries are very beneficial in trying to get a collaborative robot in, because it gives you that kind of feeling of, here's a robot, kind of work around with the robot. This is kind of how everything kind of works together. There's a lot more safeguards in place with a collaborative robot as well, because everything is a lot more touchy on, torque limits and safety limits as well as that. So it makes everything integrating a lot easier for a beginner person.
This machine needs to go in and be running over a weekend because they can't shut down their line. And it also needs the flexibility to be able to revert to manual should something go wrong where the boxes aren't behaving the way they're expected to, and we want to go back to manual for a shift or two.
As we were coming through your facility, we saw some autonomous robots.
Yes.
And can you tell us a little bit about how that may affect food and beverage too?
Yeah, we're seeing a lot of interest from food and beverage customers for autonomous mobile robots. So it's like a robotic cart. It doesn't require a fixed path, so it can interact in a live space with forklifts and humans. And even with a cart that was left in the way, it can navigate around that. But we're really seeing them both in roles where you would have maybe used a forklift to move a heavy load, but also in roles where we're just supplying a little bit of product to sort of a Kanban station or smaller totes of delivering like popsicle sticks rather than a finished product.
And on our tour as well, you showed me two Scara robots with two flex feeders. So can you tell us what that's about?
Sure. Often people are getting a product in bulk and then they want to get it into singles, and maybe that product also needs some quality checks. So with that feeder, you can pour a whole bunch of something out onto a shaker. It shakes them so that it singulates the parts, and then we're using a camera to find them and a robot to pick and place them into whatever orientation we want. So it's a really great picking, sorting solution, and fits in a very small space. We've been seeing uptake from customers where we're retrofitting machines we built in the past with this new solution. And if you're running 2 shifts, it usually has a 1-year payback period.
Wow, 1 year is very fast.
Yeah, it makes it a no-brainer, especially when you're having trouble recruiting people in general. So the 1-year payback is almost like secondary to the fact that you couldn't get enough people to run your factory at all.
Ben, thank you very much for taking the time to chat. I
Thanks,
appreciate
Jim.
it. Now we're going to move into the realm of what would have been science fiction just a few years ago. It is the metaverse. Think 3D goggles, gaming, immersive 3D environments, and in a way, this production studio called the Immersion Room. Now let me explain the metaverse a bit more for all of you. If you're over 40, then you'll remember a time when the internet sounded like a strange concept. Even in the early days, none of us could imagine how having an access to an online library would change our day-to-day lives. The metaverse is at a similar stage today. What you need to know about the metaverse is that it is a virtual world. Just like normal life, it continues to exist and evolve even if you're not paying attention to it. And just like your real-world neighborhood, once you take a step into the metaverse using a virtual reality headset, you can socialize, create, as well as buy and sell goods using digital funds like Bitcoin. Although you can't eat real food in the metaverse, you can still order it. Chains like McDonald's are already snapping up virtual real estate, aka unreal estate, so that you can order food to be delivered to you within the metaverse. But this trend isn't just for big companies who have lots of brick and mortar locations. Consider Famous Cosmos, the much-loved Montreal diner. In January, they invested $15,000 on a space in Decentraland, a metaverse neighborhood. They plan to make money by working with ghost kitchens across Canada that will be able to fulfill online orders placed by metaverse users who crave their signature menu items. Famous Cosmos will also sell virtual food for your metaverse avatar to eat and to share with others. And so how does this connect to our next feature company? Ghost kitchens are food prep operations with no waiters, no dining room, and no parking lot, and hence the word ghost. Fairly new to Canada, but a mainstay in other parts of the world. Now we're going to take you to a ghost kitchen which has its roots in Canada in Uber, in late night cravings, and has been made more popular because of the global pandemic. What is interesting about the ghost kitchen concept is that they can empower the metaverse. You're playing a game, you're hungry, you need a hamburger and fries. Within the metaverse, it's not a problem. You can order in the virtual world and have your meal delivered in the real world. You can send and share the same to your gamer friends. Or you can be like us, visit a ghost kitchen in real life. So we've been talking a lot about robots and automation, and we're here in a little bit different locale, and I think it's really important to the conversation. We're in Canada's leading ghost kitchen. So if you haven't heard of a ghost kitchen before, a ghost kitchen is a kitchen without tables and chairs. It's got customers certainly, but they're either pickup customers or they're delivery customers. What's really interesting and fascinating about ghost kitchens is that they can produce over 20 different food brands right from one single kitchen. So all of a sudden, for ghost kitchen brands, when they go to scale, right now they're at 22 stores across North America, they may have up to 1,000 stores in Walmarts and in other locations. So what's really interesting for the brands is that they can be in hundreds of stores in a matter of maybe weeks or months. So from both people win. Customers win because they can choose up to 20 different brands of food offerings, and brands win because they can be in hundreds or thousands of different stores. So we'll take a look and we'll do some ordering and we'll have a test drive. Of course, you can order from home, you can order on your phone. We happen to be in store. So I think CFIN is paying for this. So I'm going to order a Jogenfruz. And I'm going to get this strawberry cheesecake, and I'll order large, and I'll add to the order.
Let's go for raspberry. I'm going to go for small.
Ben & Jerry's half baked. I'll take one, and I'll add to the order. Beaver tail.
And classic.
Classic. Add to order.
That was easy. So we just wait a few minutes and wait for our order. To showcase our next example of robotics and automation, we took a dinner break and had a visit to 168 Sushi, where we met Bellabot, a service robot who is becoming quite the server for her guests. Mix equal parts of fun, service, and novelty. And all that, and I forgot to take a selfie. So to round out our conversation on robots and automation and food, we're here at Sushi 168 restaurant, and we've just ordered some sushi, and we're just waiting for our order to arrive. So Bella, the robot made by Bellabot, it can act as a host, so it can bring you to your table. It can act as a waiter or waitress and bring you food, pick up food, and also can sing you happy birthday in 4 different languages.
Here I am.
Hi. This is great.
Oh, 1, 0. Dear guest, your meal is ready. First, tray with blue light on is your meal. Be careful when picking it up.
Thank you so much.
Thank you. Bye.
Bye. See you soon.
Jamie, what I think is really an interesting part of this story is, especially in food service delivery for this type of robot, is it better than a waitress or a waiter delivering food? Is it faster? Is it more efficient? You can't even hire people. So I think that there are some pluses and minuses, but one of the things I've been reading online from some of the reviews of 168 Sushi is that kids and people are really entertained by having a robot serve them. So I wonder sometimes if it's about a customer attraction, right?
Yeah, I don't know. There's something kind of exciting about, getting your food from a robot and interacting with the robot. I mean, just when I picked these plates up it said, grab from the top tray. And I thought that was exciting and something very back to the future too about it. That definitely draws people in. So it's kind of like a novelty niche thing to, get to go to a restaurant and interact with robots. And I was thinking while we were here, maybe that kitten robot has something to do or knows Sally, the salad robot that we saw at Western. I don't know, they might be part of the same AI family.
They could have gone to school together.
I see what you did there. But yeah, I think this is exciting. This is definitely the future, and we're gonna see more and more and more of this. So it's kind of cool to be on the cutting edge right now and catching it before it's the total wave.
Absolutely, I think you're right. So I think the interesting conversation here is about automation and robotics, whether it's in a food or restaurant environment, is what is the ROI? Is the ROI in bringing more people into your restaurant, or is it in saving money because you can't hire servers and you can't hire hosts? So I think it's a fun, interesting conversation. I tend to think that it's a little bit more on the customer attraction side of the restaurant business right now, but I do see a future where almost all restaurants will have some kind of automation in-house. So I think it's a fun conversation to have. I'll leave it to you guys to think a little bit more about it too. At CFIN, we're all about fun surprises, and we have a surprise celebrity guest for you today to help wrap up our program. Please help me welcome a robot famous on the downtown streets of Toronto. Please welcome Jeffrey, the last mile delivery robot. Jeffrey, do you have something for me? Nice, you bring me a drink at the end of the show. Well, I'm keen to learn more about you, so why don't we talk to our friend at Tiny Mile. Hello, we're back in studio, and I've got Sharif Farani from me, who is the head of growth at Tiny Mile Robotics. And you're a Toronto-based manufacturer, correct?
That's correct, yeah. Our tiny factory is located right here in the heart of Toronto, and they're made by Canadians for Canadians.
That's very cool. And can you tell us a little bit about Jeffrey, your robot?
Yeah, for sure. Jeffrey is your modern-day postman in pink. He's truly neighborhood, local delivery, and he's low impact, low emissions, low cost, and the whole goal of it is to make delivery more accessible to people in your local delivery kind of neighborhood and promote a diverse business ecosystem.
And so what kind of things are you delivering?
We're delivering anything from food to small retail and groceries. And the interesting thing about Jeffrey is our way that we approach robotic design. So, the normal kind of robots that you see in the US are operating around other parts of the world are autonomous robots. Well, we've decided to approach it in a human-centric form of robot design. And so what that means is our robots are really meant to work in cooperation with humans. And so they're actually teleoperated, remotely operated by pilots. And it makes them a little bit more safer and adds that extra level of trust to them as well. We're one of the only robot designs out there that have a 360 camera, so it gives quite a viewpoint when you're looking from the driver point of view.
And your clients are, say, downtown restaurants in Toronto?
Our clients are downtown restaurants or suburbs as well. We're operating right now in the US in Charlotte. Charlotte's one of the most technologically innovative cities in America, and so we found it as a great testing ground for Jeffrey.
And so what are some of the technological challenges that you've had to address?
Weather is definitely something that's always been a challenge, but fortunately for us, Jeffrey can go in about 4 inches of snow. But also the street conditions are something that we're testing to see as well. What are the limitations in that capacity?
So the future is kind of fun for you?
The future is definitely fun, and the future is pink right now, for sure.
That's wonderful. Well, thank you so much for joining us today at this CFIN event.
No problem. Thanks for having me.
And now let's take a bit of a break from all this robot talk and invite a good friend from CFIN to tell you about another exciting initiative that's changing the food business. Now over to Dana McCauley, Chief Experience Officer at CFIN. Dana, I'm feeling a little bit like a news anchor.
Thanks, Jim, and hello, CFIN members. Thanks for joining us for this CFIN experience, Robotics in Action, Seeing is Believing. I've been very inspired today by the things we've seen. There's obviously a lot of very smart people in Canada who have great ideas for improving the food business. But as much as we know that there are lots of great ideas out there, we also hear from you that you struggle sometimes to find the partners and the resources and knowledge, and sometimes even the funds that you need to bring all these great ideas to market. So at CFIN, we think we've got an answer that'll help you to do all of those things more easily. Instead of telling you about it though, I think I'll just show you.
Canada's food industry is led by small and medium-sized businesses in every region of the country who work to bring Canadians safe and healthy food and beverages. Yet all these individual businesses all exist in a vast economic ecosystem, better known as Canada's food industry. Connecting with research and industry partners outside of your direct supply chain can often be a difficult and costly endeavor for small and medium businesses like yours that form the heart of our food supply chain. Food businesses could be missing important opportunities to collaborate, innovate, and grow their business, all while valuable research is lost when different sectors of the industry can't connect, much less communicate. Meet Yodel, a first-of-its-kind platform brought to you by the Canadian Food Innovation Network. CFIN is a national nonprofit organization that's stimulating innovation across the Canadian food sector. On Yodel, Canadian businesses and their partners can network, share innovative solutions, and create connections that will help build a stronger, more sustainable food industry. You'll discover information on funding opportunities, best business practices, consumer trends, new R&D and technology, and food safety impacting every sector of Canada's food industry. You can access direct one-to-one mentorship from CFIN's 5 regional innovation directors, who are dedicated to helping you access funding, identify partnerships, and facilitate collaborations to grow your business. No matter where you and your business fit into the food supply chain, from farm gate to dinner plate, there is a place for you on Yodel.
So thanks for sticking with us to the end. Our conversation today makes me wonder, will ghost kitchens be using Rowalk and gastronomous robots or some form of robotics? And will we be seeing a line of tiny mile robots coming out of ghost kitchens in Vancouver and St. John's? Will perfectly grown mushrooms be singulated into special containers for robots and automated kiosks? Will more service robots be delivering plates in food service as a valued staff member or as a novelty to attract customers and selfies? In ending, I want to note that robots aren't taking our jobs. Robots are a tool. They perform tasks, the dirty, dangerous, monotonous, and boring tasks that humans are not good at and that people don't want to do. Humans, compared to robots, are good at thinking, problem solving, anticipating, and planning. A big thanks to all the companies and individuals that contributed to our presentation today. We learned a lot and we're excited for your success, and we'll be watching you. We'll be ordering food from you, and we'll be checking out your machines, your bots, your ghost kitchens, your kiosks in hotels, universities, and airports. And we'll be eating your mushrooms that are automatically grown, picked, and packaged. Thanks to our sponsor, FCC, and to all of you for joining us today. No robots were harmed in the creation of this presentation. Thank you for joining us today. Be safe out there. We'll see you next time.